Okay, in this video, we're going to be doing 24 AP Calculus multiple choice practice problems that will apply to both the AB and BC exams. These problems are going to come from the 2012 curriculum framework. They are still relevant and still useful. Let's take a look at the problems. Number one, what is the limit as h approaches 0 of cosine of 3 pi over 2 plus h minus cosine of 3 pi over 2 all over h? As soon as you see the limit as h approaches 0, you should be thinking limit definition of the derivative. If that's the case, we are finding the derivative of cosine. So our function would be cosine. We're going to find the derivative of cosine, which is going to be negative sine. So these are things that you should have memorized. And now we just need to know what we're plugging in. Well, I mean, if you look at the problem, we're pretty clearly plugging in 3 pi over 2. So I'm going to find f prime of 3 pi over 2. So I'm plugging 3 pi over 2 into negative sine of x. You have to remember your unit circle values. This is a quadrantal, so some people just draw the circle and label the quadrantals. But the sine of 3 pi over 2 is negative 1, so we're going to get the negative of negative 1, which is positive 1, so our answer is A. Number 2, at which of the 5 points on the graph in the figure at the right are dy dx and the second derivative both negative? All right, so we need to know what it means when dy dx is negative and when the second derivative is negative. I never really know how to pronounce that thing, so I always just say the second derivative. If dy dx is less than 0, that means that our function, which is called y, must be decreasing. If you look at the problem, it kind of only looks to me like B and C are points where this function is really decreasing. And then the second derivative being less than 0 means that our function is concave down. Of the two options that we have, at B we are concave down, at C it looks like we're concave up. So I'm going to say that my answer is B. 3, the slope of the tangent to the curve y cubed x plus y squared x squared is equal to 6 at 2, 1 is, and we got to find that. So step 1, we're going to find the derivative with respect to x of everything in this implicitly defined function. So that's d dx of the left side equals d dx of the right side. The left side's pretty interesting. We're going to have to use the product rule twice. So we're going to do, so that y cubed times x, right? First and second. So it's first, derivative of the second is 1. Plus second, which is x, derivative of the first is 3y squared dy dx. Don't forget the chain rule on that, and you'll get the problem right. All right, then we have to do the product rule again. So it's plus first, which is y squared. Derivative of the second is 2x. Plus second, which is x squared. Derivative of the first will be 2y dy dx again. So when you're doing this, you're always using the chain rule on y, so you're always going to get a dy dx. Don't forget the derivative of a constant is 0. That's the number one mistake I see people make. Now, we're going to plug in 2, 1. Instead of like algebraically simplifying this, it's much easier to just do algebraic stuff, or arithmetic, I guess I should say, not algebraic. All right, so x is 2, y is 1. So we're going to get 1 cubed times 1 is 1, plus 2 times 3 times 1 is 6 dy dx, plus 1 times 2 times 2 is 4, plus 4 times 2 times 1 is 8 dy dx equals 0. So it's like 5 plus 14 dy dx. So subtract 5, divide by 14. Dy dx is negative 5 over 14. So our answer looks like C. 4, let S be the region enclosed by the graphs of y equals 2x and y equals 2x squared for 0 to 1. What is the volume of the solid generated when S is revolved about the line y equals 3? All right, so the first thing I notice here is where we're going around y equals 3, which is a horizontal line. That's kind of like the normal thing. It's kind of like going around the x-axis, so everything should be in terms of x. I'm going to just cross out D and E because they're in terms of y. Now I'm going to go from here. I'm going to graph this thing. So we have this. We just need a line and a quadratic. You need to get them in the correct order, but the line is definitely above the quadratic on this interval. Just think about what x squared looks like versus x. And I mean, it's the same basic situation. We're going around y equals 3. So y equals 3 is above, and that's going to be relevant to what we end up doing. So we have this. You're going to get a big radius when you rotate, right? Because that's the farthest you can get from the axis and still stay in the region. And you will also get a small radius when you rotate. So now we just need to figure out the big radius and the small radius. The big radius, we're going to do top take away bottom, so 3 minus 2x squared. The small radius, we're going to do top take away bottom, so 3 minus 2x. And now we'll just write our volume. So it's going to be pi, the integral from the bounds. In this case, we're just given 0 to 1. So pi, the integral from 0 to 1. Big radius squared. So it's going to be the quantity 3 minus 2x squared squared minus little radius squared. So that's going to be the quantity 3 minus 2x squared, and then dx. Then we just look at the answer choices. As a person who kind of suffers from dyslexia, I hate these problems. It's very hard for me to choose between these. Pretty sure the answer is A. 5. Which of the following statements about the function given by f of x equals x to the fourth minus 2x cubed is true? All right, so you look at the answer choices. They're all about relative maximums, minimums, and points of inflection. So we're going to have to do a sign chart analysis of this. So step 1, I'm going to find f prime. So f prime, just the power rule. So it's going to be 4x cubed minus 6x squared. I'm going to factor that to get, I'm going to take 2x squared out, and then we'll have 2x minus 3. All right, but you go back to the non-factored form to find f double prime, which we need because we need to talk about points of inflection. So power rule that thing. I recommend that you always use the non-factored form for this, especially because it's just a power rule. If you use the factored form, you have to use the product rule. Not a big deal, but a little more challenging. This we can factor too. You can take a 12x out. Factoring these is kind of essential to getting your sign chart set up correctly, right? So for f prime, I know that the zeros are 0 and 3 halves. For f double prime, I know the zeros are 0 and negative 1. So, I'm sorry, 0 and positive 1. All right, so I'm going to set up my sign charts. We got f prime, f double prime, 0 and 3 halves. And then what we want to do is we want to put the numbers for f double prime in the correct relative location. So the 0 will go with 0, and then 1 has to go between 0 and 3 halves to make sure that we're lining things up correctly in the event that we need to do increasing concave down or decreasing concave up, something like that. Let's figure out signs on intervals, right? So if I plug in negative a billion to f prime, I'm going to get a negative squared is positive, and then a very negative second term there, so negative overall. 0 comes from a second degree factor, and since it's a second degree factor, there is not going to be a sign change, or just keep testing. So you could test 1, for example, and that would definitely give you a negative. And then if you plug in positive a billion, you're going to get positive, or you could say 3 halves comes from a factor that is first degree, so there will be a sign change. All right, for f double prime, I look at that and I'm like, it's a quadratic that opens up, and they always just go plus minus plus. So that's what I'm going to do. Another option is to just test your regions. So this is what we have so far. Let's look at the sign charts and see what they tell us. So 0 on f prime, no sign change, nothing going on. At 3 halves, there's a sign change. That's actually a relative minimum, but the problem only talks about relative extrema. It doesn't talk about minimums and maximums. And then for f double prime, we have a sign change at 0 and at 1, which means we have points of inflection at both of those. So we actually have 2 points of inflection and 1 relative extrema. Now you have to go through the answer choices. So A, the function has no relative extrema, that can't be it. B, the graph of the function has 1 point of inflection, that can't be it. C, the graph has 2 points of inflection and 1 relative extrema, that is the answer. We don't really need to look at D and E because they're just not right. So our answer is C. 6, if f of x is sine squared of 3 minus x, then f prime of 0 equals. This is just a straight chain rule problem. You do run into problems like this on the AP exam. They tend not to show up on too many practice problems because they're so straightforward that it seems like, why are we spending our time practicing things we are definitely good at? But let's do this. So I'm going to color code and rewrite it a little bit. So instead of sine squared, I'm going to write it as the quantity sine of 3 minus x and then squared. So it's a little more overt what the outer function is. So the derivative of something squared, so f prime, is going to be 2 times that thing, so 2 sine of 3 minus x to the first times the derivative of that thing. The derivative of sine of something is cosine of that thing. So we get this times the derivative of that thing. The derivative of 3 minus x is negative 1. And then the question is to find f prime of 0, so we're going to sub in. So f prime of 0 is going to be, well, there's definitely a 2. You get the sine of 3. You get the cosine of 3. And these aren't famous values, so there's no more simplification that you can do. And then a negative 1. So our answer looks like negative 2 sine 3 cosine 3, which is definitely B. 7. Which of the following is the solution to the differential equation dy dx equals 4x over y, where y of 2 is negative 2? So the first thing I notice is that y of 2 is negative 2, and if you look at the answer choices, answer D is a positive square root, and that'll never give you a negative, so we can cancel it. Also, our solution needs to be continuous on an interval that contains the initial condition, so you can actually cross out B as well, because that is not a continuous function. So let's cross that out. Okay, now I'm going to actually solve the differential equation. So I'm going to color code it, which is what I like to do in the videos. I don't really do it in the real world, but it's useful. Everything with a y goes on one side, everything with an x on the other side. So we'll get y dy is 4x dx. We got to throw some integral signs in here and then just integrate. In this case, it's reversing the power rule for both. So 1/2 y squared is going to be 2x squared plus c. I don't think there's going to be an easier time to solve for c, so I'm going to solve for c now using our initial condition that y of 2 is negative 2. So plug in negative 2 for y, we get 4 over 2 is 2, equals plug in 2 for x, and we get 4 times 2 is 8 plus c. So c is definitely negative 6. We can't use that to eliminate anything yet because we actually have to go through and solve for y. So let's take the thing that we have and we'll just replace c with negative 6. So this is where we stand. I'm going to multiply everything I see by 2. I like to do extra steps on this. A lot of people skip things. I don't know. I think it's better to do more steps on this particular type of problem. It's your call. I'm going to take the square root. I get plus or minus, which cannot be the answer. I mean, it's not an option really from the options at this point, but in general, that can't be the answer because that's not a function, right? For any x value, there's 2 y values. Use the initial condition to decide if it's positive or negative. So y of 2 is less than 0, which means that we have to choose the negative square root. So I get y is negative square root of 4x squared minus 12. If you look at the answer choices, that is definitely C. That's the answer we have to go with. There is this domain issue, which I'm going to address, but you don't really need to worry about because it's multiple choice and you're done. But if you look at it, we are taking a square root. So what we really need is we need the thing inside the square root, which I'm going to write in factored form here, to be positive and to contain the initial condition. So if you make a sign chart for this, you'll have negative root 3, you'll have positive root 3. So either your answer was going to be for x less than negative root 3, between negative root 3 and root 3, or greater than root 3. In this case, because x is 2, we have to choose x is greater than root 3. But anyway, our answer was C. 8. What is the average rate of change of the function f given by f of x equals x to the fourth minus 5x on the closed interval from 0 to 3? Average rate of change is algebra 1 slope, so we're just going to find the slope between 0 and 3. So what we're basically doing is f of 3 minus f of 0 over 3 minus 0. That's all this is. If you know what average rate of change means, you could do this problem in algebra 1. So when we plug in 3, we get 3 to the fourth minus 5 times 3. And when we plug in 0, we just get 0, thankfully. And then we have to divide by 3. What I'm going to do to simplify the calculation is I'm going to actually divide everything by 3. So 3 to the fourth over 3 is 3 cubed. And then 5 times 3 divided by 3 is just 5. So really we get 27 minus 5, which is 22. So our answer is C. 9. The position of a particle moving along a line is given by s of t equals 2t cubed minus 24t squared plus 90t plus 7 for t greater than or equal to 0. For what values of t is the speed of the particle increasing? So speed is increasing when velocity and acceleration have the same sign. We're going to do some sign chart work on this. All right, so I need to find v of t. On the free response, you have to connect v to position. So I'm going to say that v of t is s prime of t. I'm going to use power rule, so I get 6t squared minus 48t plus 90. I'm going to immediately find the acceleration. So acceleration is the derivative of velocity. I'm going to connect those two just in case. Use the power rule on this. We'll get 12t minus 48. All right, we're going to do sign chart stuff, so I really have to factor that first derivative. So I'm going to go up here. You can take a 6 out, and you get t squared minus 8t plus 15. And then t squared minus 8t plus 15 will factor. You get minus 3 and minus 5. So t minus 3, t minus 5. All right, our sign charts are going to be for v of t and a of t. Going to look like this. On v of t, we'll put the zeros of v of t, which are 3 and 5. And then on a of t, in the same relative position it would go on this chart for v of t, I'm going to put 4. So right in between 3 and 5. All right, v of t, plug in negative a billion, or it's a quadratic that opens up, so it's going to go plus minus plus. But you know that you're getting positives in this region, you're going to get negatives in this region, and you're going to get positives here. So I think of it as a quadratic that opens up, but feel free to plug in values. It's like the time-tested way of doing it. For a of t, I don't know, if you plug in 0, you definitely get negative 48. So negative on this side, and then positive on the other side. Plug in a billion, see what happens. All right, so we are looking for where velocity and acceleration have the same sign, and you can see that that happens here and here, so between 3 and 4, and then greater than 5. Look at your answer choices. The answer is E. 10. Integral of the quantity x minus 1 times square root of x dx. This is just a straight integration problem. We got to find an antiderivative. I'm going to change square root of x into x to the 1/2 and distribute it. So I'm going to turn the integrand into x to the 3/2 minus x to the 1/2 and then dx. So in both cases, we're just reversing the power rule. So we're going to add 1 times the reciprocal. So plus 1 times the reciprocal. Add 1 to 3/2, you get 5/2. So 2/5 x to the 5/2. And then add 1 to 1/2, you get 3/2. So it'll be minus 2/3 x to the 3/2. And then plus c. This is a pretty straightforward problem, but you do run into these sorts of things on the exam. So I'm going to say my answer is D. 11. What is the limit as x approaches infinity, x squared minus 4 over 2 plus x minus 4x squared? We could use L'Hopital's on this because you do get infinity over infinity. If you use it once, you'll get 2x over 1 minus 8x, which is still infinity over infinity. Use it again, you'll get 2 over negative 8, which is negative 1/4. The answer is negative 1/4. I'm going to do this the old school algebra way instead. So what I'm going to do is divide everything I see by the highest power of x in the denominator. So I'm going to do x squared over x squared is 1, 4 over x squared, all divided by 2 over x squared, 1 over x, and minus 4. So I just want you to be aware that there are other ways. Like, don't rely on L'Hopital's for everything when you can get the answer in another way. If x goes to infinity, everything that has x in the denominator now is going to go to 0, so we just have 1 over negative 4. We have negative 1/4 is our answer. B, which we already knew. 12. The figure above shows the graph of y equals 5x minus x squared and the graph of the line y equals 2x. What is the area of the shaded region? This is like a real calculus problem. Like, not, I mean, I guess it's conceptual, but we actually have to just like do some algebra stuff. We have to find the intersection point. So we need to know where 5x minus x squared intersects 2x. Just move everything to one side. You're going to get x squared minus 3x equals 0. You factor that and get x times x minus 3 is equal to 0. And now you're like, this is why we learned to do all this stuff. X is equal to 0 or x is 3. So really we need that intersection point, which is 3 comma 2 times 3, so 3, 6. All right, so to find the area, we're going to do the integral from 0 to 3 of the top curve minus the bottom curve. So 0 to 3. Top curve is definitely the quadratic, so that's 5x minus x squared minus the bottom curve, which is 2x. I like to put the thing that I'm subtracting in parentheses, even if there's not like negatives and distributing. You're just going to make fewer mistakes that way if you like start off doing that. So top minus quantity bottom. All right, if we clean this up, we get 0 to 3 of 3x minus x squared. Now we're going to reverse the power rule. So 3/2 x squared minus 1/3 x cubed. We are going from 0 to 3, fundamental theorem. When we plug in 3, I mean, I'm just going to, plug it in. So we get 3/2, 3 squared minus 1/3, 3 cubed. When you plug in 0, everything goes away. So you actually just get minus 0, which is really nice. 3 times 9 is 27 over 2, and then you have 27 over 3 is 9. So that, and then that's 27 minus 18 over 2, 9 over 2. Our answer is B. 13. If y equals 5 plus the integral from 2 to 2x of e to the negative t squared, which of the following is true? All right, so the first given information is derivative, so I'm going to find the derivative. So dy dx. This is going to be the second fundamental theorem, so we're going to take the upper bound, which is 2x, and sub it in for every t that we see in the integrand. So that'll be e to the negative quantity 2x, and then squared, times, by the chain rule, the derivative of 2x, so times 2. And then this cleans up to 2e to the negative 4x squared. Look at the answer choices, and you can definitely eliminate A, B, and C. So those are out. Now we just have to choose between D and E. Look at the next piece of information that they're asking you. So either you have to plug in 0 and see what you get, or plug in 1. I'm going to plug in 1 because I'm pretty confident that I know the answer at this point. So at x equals 1, we're going to get 5 plus the integral from 2 to 2 of e to the negative t squared dt. The integral from a to a of anything is going to give you 0. So from 2 to 2 of blah is definitely 0. So we just get 5 plus 0, which is 5. So the answer is definitely E. If you had chosen to plug in 0, you actually would have kind of struggled because you wouldn't be able to figure out that definite integral. But no matter how you choose to approach it, the answer is E. 14. Which of the following is a slope field for the differential equation dy dx equals x over y? There's actually a slight chance you might have memorized this slope field. It kind of is famous and comes up a lot. But my approach to this, I think what I'm going to do first is I'm just going to say, if y is equal to x, we can really simplify this, right? If y is equal to x, then you just get x over x. So dy dx simplifies to 1, which means everywhere on the line y equals x, the slopes should be positive 1. If you look at these things, like on A in the third quadrant, the slopes are negative. B, there is a linear solution, but it's not going through 0, 0, like y equals x does. C, all kinds of problems. D, still not working. The answer is just going to be E. So based on this piece of information, we can cross out these 4 and select E. But what if that wasn't enough, right? So I'll give you one other thing we could look at, but we already have the answer, so I don't want to really belabor this. And also I have some really good videos on how to match a slope field to a differential equation. But if x and y have the same sign, meaning you're in quadrant 1 or you're in quadrant 3, then dy dx should definitely be positive. And based on that alone, we could have crossed out A, B, and D, and then we would just have to choose between C and E. So making a choice at the beginning really narrows it down. And that's really all you can do on these, is narrow them down until you know which one to choose. Anyway, our answer is definitely E. 15. A particle travels along a straight line with a velocity of v of t equals 3e to the negative t over 2 sine of 2t meters per second. What is the total distance in meters traveled by the particle during the time interval 0 to 2 seconds? Distance traveled is the integral of the absolute value of velocity, or the integral of the speed. So we are just going to do integral from 0 to 2, absolute value of v of t dt. I'm going to switch over to the calculator. I'm going to let the calculator do all the work. I will come back and I will just box the answer. And so from that, we could see that the answer is 2.261, or D. Now, there's another way you could approach this if your calculator can't do what we did, which is totally possible. If your calculator can't do what we did, I'm going to go back into the calculator, do it a slightly different way, and then come back and write out my work, and then I will, select D again, I guess, basically. So back to the calculator. All right, so in my work, if this was free response, what I would do is I would say let b equal 1.5708, and then I'm going to say that the distance traveled is going to be the integral of velocity anywhere velocity is positive, and then minus the integral of velocity anywhere velocity is negative. So I would set this up. Doing this calculation, we saw got the exact same answer. 16. A city is built around a circular lake that has a radius of 1 mile. The population density of the city is f of r, people per square mile, where r is the distance from the center of the lake in miles. Which of the following expressions gives the number of people who live within 1 mile of the lake? All right, we're going to have to start off with a drawing, so I'm just going to draw a circle. Has a radius of 1 because it's our lake, right? I'm going to draw a circle around that, and it's going to be my city. The city is within 1 mile of the lake, which means that from the center of the lake out to the edge of the city is going to be 2 total miles. So looking at this, we know that we're going to have to go at least until 2 in our integral. which means we can eliminate A and B because those are just going from 0 to 1, which means you're like inside the lake, and that is definitely not what we want. Also, if we include 0 to 1, we're still including the lake, so I think we can also eliminate C as an answer. I should say up front, I think this is the hardest problem in this entire set of problems. I have an entire separate video that talks about how to deal with radial density functions. They're unique. They do come up on the exam, obviously. These are the practice problems, but they're kind of a one-off thing. So from here, what I want to do is kind of like work out the answer, right? So I'm going to put another ring, and I'm going to say that this distance right here is going to be delta r, right? A little change in the radius. And then from the center out to there, I'm going to say is r sub k, like our evaluation point. So what I'll do is so we have this blue ring and a green ring. I'm going to cut that and expand it, and it basically makes this rectangle where the dimensions are the circumference of the green circle, so 2 pi r sub k, and then delta r, which means that has an area of just 2 pi r sub k delta r. To find the total number of people living in this strip, it's going to be the area times the density within the strip, right? Because density is people per square mile and area is square miles. So area is, as we mentioned, just base times height for a rectangle at this point. So 2 pi r sub k delta r. Density, we're told, is f of r, so f of r sub k in our case. Now, if we add these up and take a limit, we know that r sub k just turns into r, and we know that delta r is going to turn into dr. So this, in our integral, will become 2 pi r f of r dr. If we look at the answer choices, we can see that only D fits the bill for that. I really don't know what's going on in this problem where the answer choices continually have the quantity 1 plus f of r. I'm really not sure what's going on with that. They definitely think you're going to pick that. It's in 3 of the choices. But in this case, our answer is definitely D. 17, the graph of a function f is shown above or below in our case. If the limit as x approaches b of f of x exists and f is not continuous at b, then b equals. All right, so I actually think the easiest thing to start with is continuity, right? Like, where is this thing not continuous? So that's going to be at -1, at 0, and at 2. Now what we need is for the limit to exist. So if you look at it for at -1, you have a vertical asymptote. The limit definitely does not exist. At 2, you have a jump discontinuity. The limit definitely does not exist. At 0, the limit from the left and the limit from the right are both 2. The limit does exist. Our answer here is B. 18, let f be a function such that f double prime is less than 0 for all x in the closed interval 1 to 2. Selected values of f are shown in the table above. Which of the following must be true about f prime of 1.2? All right, so for this problem, I'm first going to think about what does it mean for f double prime to be less than 0. That means that f prime is decreasing. Okay, so that's some information. Now, using the table, what I can do is I can look at average rates of change on intervals immediately to the left and immediately to the right of this thing. So I'm going to look on 1.1 to 1.2. So average rate of change is algebra 1 slope. So I'm going to do f of 1.2 minus f of 1.1 over 1.2 minus 1.1. And you can look, that's 4.38 minus 4.18 is just 0.2 over 0.1, which gives us just 2. So our average rate of change on 1.1 to 1.2 is 2. Now let's do it again, but from 1.2 to 1.3. The arithmetic here is like slightly harder, I guess, because you have 4.56 minus 4.38. I don't know. So that's going to give us 0.18 divided by 0.1, which is 1.8. So now we know that on the interval from 1.2 to 1.3, somewhere the slope is 1.8. And then 1.1 to 1.2, it's 2. I'm going to draw a picture. So f double prime is less than 0, so concave down. And then I'll just draw 2 things. One is steeper than the other. So you can see that the slope at the indicated point that we really want, at 1.2, is going to be in between those 2 values. So I think that our answer here is definitely going to be D. 19, 2 particles start at the origin, move along the x-axis. For 0 less than or equal to t less than or equal to 10, their respective position functions are given by x1 is sine of t, and x2 is e to the negative 2t minus 1. For how many values of t do the particles have the same velocity? All right, this is definitely a calculator problem. What I'm going to do is I'm going to switch over the calculator. I'm going to graph the derivative of both of these given functions on the interval from 0 to 10 and just count how many times they intersect. I think that's the only thing we can do. So I will be back in a second to box an answer. And from all of that, we can see that the answer is 3 times, so D. 20. The graph of the function f shown above consists of 2 line segments. If g is the function defined by g of x equals the integral from 0 to x f of t dt, then g of -1 equals. All right, so first thing I'm going to do is just going to write down what g of -1 is. G of -1 is going to be the integral from 0 to -1 of f of t dt. I look at that and I think that's sort of problematic because -1 is less than 0, so I'm going to swap the bounds and change the sign. So this will be the same as the negative of the integral from -1 to 0. You always want to be going from left to right because then everything just works the way that you kind of memorized it. So I will always switch the bounds and change the sign. Let's do some geometry. So on our figure, we have to go from -1 to 0, which is kind of this region right here. That's definitely a triangle, so the area of that's going to be 1/2, the base is 1, the height is 2. So the area of that region is +1, but we're just subbing that in for the integral from -1 to 0, so we're going to get the opposite or negative of the thing we got. So -1, our answer is B. 21, the graphs of 5 functions are shown below. Which function has a non-zero average value over the closed interval -pi to pi? Okay, so average value is the integral divided by the interval. So we're going to integrate these functions and then divide by the interval. But the key thing is if we're going to get 0, then the integral from -pi to pi has to give us 0. You can visually look at these, I think, and see that for A, B, C, and D, if we integrate from -pi to pi, kind of by the symmetry above and below the axis, we're definitely going to get 0. So I think that the answer here is E. We can go into a little more depth. If we have an odd function, then the integral from -a to a is definitely going to be 0. So for every odd function, that is true, which means this is odd, we can cross it out. This is odd, we can cross it out. This one's even, but I think we can still cross it out because if you look at the regions, right, we got like this thing and we got this thing. Those are definitely going to cancel each other out. And then similarly, these regions are going to cancel each other out. So that's going to give us 0 anyway. And then for D, also odd, so we can cancel, or we can say that that is not our answer. So from that, I'm thinking we can definitely pick E. If we fill it in, you can see these regions below versus these regions above. There's no way that the regions above are going to cancel out the regions below. This answer has to be E. 22, a differentiable function f has the property that f of 5 is 3 and f prime of 5 is 4. What is the estimate for f of 4.8 using the local linear approximation 2f or 4f at x equals 5. So the first thing I look at is I see local linear approximation. That is just fancy talk for tangent line. So we're going to write the tangent line and we're going to plug in 4.8. That's basically what the problem says. So tangent line, we're going to do y minus the y value equals the slope, and then x minus the x value, right? Point slope form all the time. We need to approximate f of 4.8, so on free response, make sure you use the approximately equal to sign. Here it doesn't matter that much, but always do what you should do, right? And we just plug in 4.8, right? So I move the 3 to the other side, plug in 4.8. So this is technically a calculator question, so I would definitely use a calculator, but here this is definitely just 3 plus 4 times -0.2, and then that's going to give us 3 minus 0.8 or 2.2. Our answer is A. 23, oil is leaking from a tanker at a rate of R of T equals 2,000 each with a -0.2 T gallons per hour, where T is measured in hours. How much oil leaks out of the tanker from time T equals 0 to T equals 10? All right, so we're going to integrate a rate to get a total. So in this case, we're just going to do the integral from 0 to 10 of R of T dt. I'm going to switch over to the calculator, type that in, I will come back, and I will box the answer. So from all of that, we can see that the answer is D. 24, if f prime of x is sine of pi e to the x over 2 and f of 0 is 1, then f of 2 equals. This is really just a fundamental theorem question. I'm going to write down the fundamental theorem, which says that the integral from 0 to 2 of f prime of x dx is equal to f of 2 minus f of 0. Once we have that written down, we're trying to solve for f of 2, so let's solve this thing for f of 2, right? Just add f of 0 to both sides. I won't make you watch me write that. We get this. Now I'm going to switch over to the calculator and let the calculator do the work. I will be back to box the answer. And from all of that, we can see that the answer is E. All right, so that was 24 really good problems. I hope you found this helpful, and good luck.